hardware faithful, but it's DMA based now, so you have a scatter gather list of stuff that
but they were all linked together, so you just start the chain and then it would kind of take care of all the...
Which I think is Widewine is kind of working the same. You have kind of a pseudo DMA protocol, I think, and this way you add stuff to the...
I think in many hardwares it's actually possible to chain DMAs.
It's exactly the same as Ethernet buffer or etc. As long as there is something to process, they continue to process it. So you need a pool, definitely. Okay.
Yeah. So I'm trying to get acceptance in the kernel for this.
So when you protect a buffer, what do you do actually, Nopti? You flag it as secure?
At the moment, I do nothing. But in a real case, I would typically involve the firewall, the DDR firewall. So perhaps I can only protect one large pool in worst case.
Because you need to protect it from access by Linux, so that means you will need to turn this memory into secure memory.
Yeah, I will have to do that.
You can make the assumption that the decoder is already flagged as secure.
Yeah, or I need to
flag it.
Perhaps it works like you tell the firewall which device IDs can access this memory. I haven't looked that closely.
Yeah, from the device point of view, yes, but from the MMU point of view, you will have to flag it as secure and that's it. So that it's not accessible anymore. So you need an external thing.
I guess that would be one of these TZ, whatever they're called, but you don't have that many entries in them to begin with. I think there's 8 entries normally, or?
TZASC, that's more than 8. Because you don't define entries, you define memory blocks.
Yeah, but I mean, you have a limited list of contiguous areas.
That's the problem. It's you have a limited list of contiguous areas. So if you allocate non-contiguous, then you are bounded to 4. It's if you look out there, there are lots of SOCs which are not using this but other solutions also.
Tell me about it.
Yeah, I know. But so that means making assumption on this is complex. But it's probably so that if you don't allocate contiguous buffer, you will run into trouble anyway.
But that's also up to the kernel driver. The T kernel driver too.
If you are not virtualized. If you are virtualized, you get the problem that you don't know anymore what is contiguous or not, which is creating kind of that's the problem we have in FFA. You have a nice contiguous buffer which is ending up in, now nothing is contiguous, so you have a bunch of pages which is dollar space. Okay.
I think I have one use case.
And what were the main remarks that you got when to reach V8? Was that only code related?
Yeah, so that was the main remark was that I shouldn't use CMA alloc directly. I should use DMA BoF alloc or something like that, and that one will automatically call CMA alloc.
Yeah.
So I get rid of lots of problems by using that one instead.
Okay.
But both problems with maintenance, but also that it's easier to
just create a CMA area and then you allocate from it.
I think you point the driver to your CMA area and then automatically everything happens in there. Or
yeah, it does.
But if you do that, then the kernel can still allocate from your memory, so you cannot flag it already as secure.
No, you have to flag it after you have allocated.
So you flag it dynamically?
Yes.
Okay.
That's
I guess you can also do a sort of
but we have
thing.
Also an alternative with a static carve-out. So that depends. That's also supported in this patch set actually, but not with FFA then.
You can do the FFA LAN up front. That would work too. If you have a static carve-out, then you know up front that you have a static carve-out, so you can do one FFA LAN at the beginning and that's it.
Yeah, I suppose you could, but I haven't done it.
Yeah, but okay.
I think somebody just earlier was showing one of these demos with linking FFA to some of these carve-outs.
Yeah, that was in the virtual message stuff.
Yeah,
where, and it's okay, because CMA you have to play each time you have allocated something, then you can flag it as secure. So you will have calls per allocation, in fact.
Yes, so the idea here is the CMA alloc is to allocate the large pool. So we only do that typically once when we set up the use case. And then when we're done with the use case, we do a free on the pool. So
but when you do the CMA alloc, the memory is not reserved by the kernel. I think there is something like that. That's why you use CMA. The difference between CMA and reserved memory is that you create a CMA pool so that when you allocate, you know that you allocate from this area, but you don't prevent others or the kernel for some needs to also allocate memory from this area. Which means if you have flagged it secure for everyone, then if the kernel is allocating also from your CMA area, then it will crash.
Yeah, but I do a CMA allocation from an area. So I get a chunk
you block the whole memory and then you play with your own internal allocation?
No, but I guess you have a big CMA pool, and from that you can make CMA allocs. And from those CMA alloc, you make another pool to make another thing.
So you do create a CMA pool, you do a CMA
I don't
alloc?
create the pool, because that's already created when the kernel builds.
Okay. So you do a CMA alloc to reserve some memory of that pool, and then you do GMA alloc on each.
And actually, I don't care about CMA. It could be any memory. It's just that when it's such a large memory allocation, usually I guess you need to use CMA to have a good chance of succeeding.
Okay, sure. Makes sense.
So I had a few other use cases in mostly brainstorming about what could be done. Secure video recording, for instance. When you have a camera and you want to sign the video stream, so it can be used to prove that it's not fabricated.
Actually, this is a much nicer idea than DRM.
It's, in a way, easier also.
But I think this actually makes a lot more sense. And I don't remember hearing about this use case before. So you have some sort of application that dumps into your trusted buffer. You sign it and then you put it on disk or whatever.
Yeah, something like that. I have no demo or anything for this. This was more like I was trying to come up with other ways you could use the secure data path patches.
Okay.
And I'm sure that there's a whole bunch of other things you can do.
It's a way to authenticate your. Okay, you use the secure area to authenticate something and sign it so that it cannot be tampered with.
Or to prove the authenticity. If you're in some. For example, in Finland they have this thing where if you take an exam, you take from a computer, like your own computer, but that boots from a special Linux that whatever school provides. So you could potentially have something like this, right? That you're in this exam room, or you take the exam at home or wherever you take it, and they take video of you.
The authenticated video is not a IA generated one.
Yeah. that it's been on this device and it's been through this camera or so.
Yeah,
so,
and timestamps and everything.
Okay, so you create a signature for the stream.
Yeah.
Okay. The cost of one memory copy. Good. Nice.
Yeah, we have of course trusted UI, but that's a lot more complicated. But I suppose it can be used as a building block in such a solution at least.
Trusted UI would mean that you turn the video output as trusted, you turn the keyboard input as trusted, and it's a messy part.
I guess in the sense is more like the first. So you have somebody that produces some video or some frames, and then you sort of pass them to some secure device or kind of muxing device or whatever. And all the other use cases are so complex that pretty much everybody, I think, has given up on this.
There is some application where when you have to enter a PIN on some security related example, what they do is that you do an overlay on top of your screen, and the overlay is generated from the secure world, and the secure world is taking over your touch screen, so that it's displaying numbers, and you hit the numbers, but those are not possible to retrieve from the normal world.
But I mean, there's almost no security in this, right? Because the problem is, you have to show the user who is controlling now. So who's showing the thing on screen? That's the first problem.
That's the overlay.
Yeah, but I mean, as a user, I look there and think, which one is the overlay and which one is the non-secure thing, right? So you cannot. It's very easy to fake it.
How did they do that?
And sometimes somebody had this bright idea that you blink a LED when it's secure.
Well, that's what you have on camera as well.
Which of course has been hacked 1 million times.
Yeah.
And then the other problem is because it's a phone. What happens if you receive a call during all this? What happens if you receive a message? What happens? What happens? Well, so like 1 million edge cases that you never.
Yeah, it's when you try to tamper with the user, the problem is you have no way to recognize if it's an overlay or not. There are some solutions for that, but they are always hacks. But yeah, I agree. But yeah, it's a bit more secure, but you can still have an application which is trying to display exactly the same thing so that it can retrieve your password. So.
And I guess maybe the main idea is that what are you trying to secure in the grand scheme of things? You would like that the ping goes directly from the user to the trusted application, but that's almost impossible to do in
usually in those cases that's purely to protect keys, which means you enter a pin so that you can activate a key.
Yeah.
But this key is not accessible. Just means that from that point on, you can request something to be either encrypted or decrypted using that key without having access to it.
So then might as well just have the pin, send it to the thing, and because there's been a lot. I think maybe 10 years ago or so, I've seen this example, which probably you basically touch the screen, and they had some fancy microphone usage or whatever, and they could detect in which part of the screen.
Yeah, there is also there was this thing with the capacity reliance also on the touch screen, where in fact once you have touch on area, if you turn the sensitivity of the touch screen, you might be able to detect where the area was touched if you are fast enough. Technology is not working this way anymore, but at some point it was capacity in the hardware. Yeah, but okay, that's all right.
That's
at the end, it's decrypting content so that you can display them. That the stuff authentication is a good thing. Signing, then but you have to trust the process, which is actually asking to do this or not, which is usually the problem.
On the bright side, DRM has failed until now, so there's no.
Everything has, well, not
Everything is hacked soon.
everything is hacked sooner or later, and every time something is hacked, we add one more layer of complexity trying to.
Which brings us more work, but I mean, we've done enough bad things for this. So.
Yeah, it's. Yeah.
Because I mean, pretty much everybody now either hacks the DRM, so the HDMI. DRM, you have those HDMI recording machines or the kind of raw interface for TVs or whatever.
Every time you try to solve something in hardware, there is someone solving it by creating some hardware which is circumventing it. And yeah, the HDMI solution so that you can ensure that the other side is actually a display and not a recorder. Yeah, but once someone has found the workaround and they create the hardware, so yeah, it's it's a sprint where you try to be faster than the other side.
Well, those guys in Shenzhen, they have all the hardware at their disposal. So.
Yeah, but at the end, I think if you look at the goal, the main goal on that is to try to protect your assets and continue to make money. So if you take the Netflix example, they know that someone will record something. But if 99% of the users, they have too much complexity to try to record and look at stuff instead of paying $9 a month, then they win. And that's the current state.
I disagree here, right? Because they only have, so you have 1 billion people that would be customers. It's enough for one to record. And then all the other billion have access, which is actually the case.
Yeah, but that's why they play on content and evolving content and changing content, so that's...
They mostly kind of bet on people being lazy enough.
Yes.
They don't want to do it. Not.
It's also the bet on my application is better, you have instant access to everything, you have, which at the end works, and that's the whole point. As long as they make more money than they lose, they will continue to do that. And right now it's also, they will continue to pay Google if Google is providing a solution that is secure enough so that they can continue to make money, and that's it. The day on which it will not be the case, then they will look for another solution, but it's
Well, let me tell you, as a consumer, I'm pretty pissed at all this, because I had some Philips smart TV at some point, and all the stuff kind of worked, and then at some point Google decided that they don't care, so they deprecated some certificates, so everything was... you can only use it. Yeah, but I mean, I paid the money for it. What's my fault that you can't update the damn thing?
No.
Yeah, you mean with the Chromecast?
No, not just Chromecast.
No,
you couldn't do anything.
TV, I have the same issue. It's on my TV. I can still watch Netflix still works, Amazon Prime still works, but Disney Plus does not work anymore because they updated the whatsoever. So you get an update from the Disney Plus application. And then you get a nice message saying that your Android system is too old. Then, in my case, you go back to Sony and you say, okay, my Android system is too old, can I update it? No, we don't provide updates. And then you end up with, okay, I can either not watch Netflix, or I have to buy a new TV. Or you do the current working solution, you buy a Chromecast, and this way you pay €50 and you have a Chromecast and you can watch Disney Plus on this. But it's still annoying. Yeah, but it's deprecation because at some point the security protocol that they used on old version of Android has been hacked so many times, and it's so complex to maintain backward compatibility that there is a deprecation. The problem is it's a lot sooner than what we expect for some devices.
But problem is that certificates just expire, right? So you have like a 10-year certificate, enough time.
Because they don't want them to renew them, because renewing the certificate is actually not the problem, it's the protocol that was used, they don't want to maintain it, so they just scrapped it, and then that's, but it will be the case, the same, we will have the same issue for everything. At some point, even if the hardware is still working, then it will not have enough safety or security or whatever, and you will have, but you will have that in cars. That will be exactly the same issue where you have a car, the engine works, everything works, but the safety guarantee of your cars are not. And that's what happened to, I think it's Porsche in Europe. There is a Europe requirement saying that you need to be able to do security updates on your car. That means they just said, yeah, too complex to update the architecture or software architecture on our cars, so deprecate. We don't sell them anymore. Okay, sure. Well, go on.
No, to be honest, this update actually, we once rented this Polestar in somewhere, and we go a little bit. There's a message showing up. You have a new update. Do you want to do it? By the way, your car cannot be used for 8 hours. If you do this update. Okay.
I had
no, thanks.
I had the same. My car. I have a Volvo, and at some point it's telling you, yeah, you have a new software update. You need to have in-house battery and etc. Also your firmware and everything. Okay. So first, I cannot use my car anymore